Welcome! This video will demonstrate setup and basic procedures for communicating with your Fusion controller using the Modbus RTU fieldbus over an RS485 serial interface. Modbus RTU is a fieldbus that allows digital communication between a PLC and the controller. There are some advantages to using Modbus RTU over an analog interface. First, it allows access to all user parameters. It eliminates analog error, and it also lowers your wiring installation costs. Before we begin, you'll need to install the control panel software, which is provided free with your controller. Connect power to the controller and connect to your computer with the USB cable. Now you will need to set up an interface between your factory controller, or PLC, and the power controller. For this tutorial, we will use an RS485 serial port connected to a laptop on COM3. Let's look at a few basic procedures. First, we will set up the slave address and communication settings on our controller. Open the control panel software. On the left-hand side of the screen, you should see USB selected as the interface. Click the Connect button. Next, choose the Digital Communication tab. You'll see Common Settings, and we'll come back to that later, and below that RS485 Communication. For this demonstration, we'll enter 1 as our Modbus address or slave address, and choose Modbus Standard Settings, 19200 for the baud rate, and E81 for the byte format. Now let's connect to the controller using the Modbus RTU interface. Select that option here and click Connect. Your available COM ports will be based on your own hardware configuration. For our tutorial, we're using an RS485 port on COM3. We match the settings to what we set up before. Slave address is 1, use 19200 and E81. Okay, we can see the transmit-receive lights are blinking, so we're getting communication. Next, we will discuss reading and writing parameters. We'll specifically look at two kinds of parameters, setup parameters and monitor parameters. Setup parameters are numbered 1 through 199 and can be both read and written to. For example, digital set point, firing modes, current limits, these are all setup parameters. Parameters 200 through 389 are monitor parameters. These are read-only. They consist of process data that you may want to monitor, like load voltage, or load current, or load power. Okay, let's look at a very typical scenario. Say we want to write a digital set point, then read monitor parameters, like load current A, and finally process the information in order to update the set point. And then we'll repeat the process. Writing a set point is accomplished with Modbus function 6, or write single register, which requires the following information. The slave ID is 1, the parameter number is 100, and as a value we want 50%, which translates to 5,000. To read monitor parameters for load current A, we use Modbus function 3, read holding registers. Enter 1 for the slave ID, 222 for the parameter number, and for bytes put 1. We recommend consulting your PLC documentation for specific instructions on how to implement Modbus for your particular controller. And you can also find Modbus specifications online at www.modbus.org under Technical Resources. The Fusion Control Panel program also has a nice feature for finding parameters. Just hover your cursor over the value or setting you're looking for, and the corresponding parameter number will appear under the cursor. We'll briefly talk about overloading. Now, if you are reading or writing too many parameters at a time, the controller may become overloaded. To avoid overloading, use block reads to collect data more efficiently. A block read consists of up to 16 parameters. Furthermore, do not pull the controller for more than 4 block reads per second. Now let's address digital communication failure. Under the Digital Communication tab on the control panel, we see Common Settings. If communication is interrupted, whether because of a cabling issue or your PLC is shut down, this is where you specify how the controller reacts. It's a known default state that you've defined. The calm heartbeat is like a watchdog for your controller. The default factory setting is 0, which stands for an infinite timeout. When it is set to 0, if there's a communication failure, the controller will continue running as it has been based on your last command. But maybe you want to be notified or take a specific action when you have a communication failure. Well, you have two options indicated by these two radial buttons: continue and stop. For our demonstration, we'll set the timeout for 5 seconds. This means the controller expects a read or write from the fieldbus at least every 5 seconds. If communication has been interrupted, it does one of two things. If you have the controller set to continue, it continues running at your last digital command until network communication is restored. We can demonstrate this by removing the cable. After 5 seconds, the controller displays a warning and holds the last command. So to restore communication, we correct the failure and make sure the factory controller, or the PLC, is communicating with the controller. Then the warning alarm will disappear. If you select Stop and communication is interrupted, the controller goes into an inhibit state and stops operating. You might choose this option as a safety precaution. It'll all depend on your specific application and preferences. Stop mode requires you to do two things to get the controller back to run state. First, restore digital communication, fix the problem, in our case, restore the cable, and make sure there is communication between the factory controller, or PLC, and the controller. Then cycle Run Reset on P1 to clear the fault. These two steps need to happen in sequence. First, restore digital communication, and second, cycle Run Reset. An additional option would be to have the controller notify an external signaling device, like a light tower or an alarm system. You can find this option under the System tab on the control panel. Choose Communication Error here to trigger Relay 1 or Relay 2 in the event of a communication failure. For more detailed instructions, visit our website at www.ccIpower.com or contact the experts at Control Concepts Incorporated.